Parallel versus series in dealing with digital circuits, digital communications. What's the difference? So this is more of an example of parallel, but I'll describe the difference in series pretty quickly after I'm done here. This is a chart that shows 9 wires being used to send an 8-bit value, because one of those wires is always going to be a clock. Whether it be parallel or series, there's going to be a clock wire in there. The clock wire pulses every time something is sent. It's the one that says, okay, all your bits are set. It is or does not read it to whatever it's communicating with. All of your other stuff, though, are your bit wires. So, you have your ones column, you have your twos column, because once again, this is in binary. This is in base 2. So it's not ones, tens, it's ones, twos, fours, eights. And that's how we add these up. So 164, the 128 bit will be set. The 64 bit will be set. And the 4 bit will be set. And all the other ones will be clear, because 128 plus 64 plus 4 equals 164. Once those are set and the other ones are clear, it's going to pulse that clock wire until the other system read it, it's good. So it's sending 8 bits at a time. In a series system, it's not going to try and send any more than a single bit at a time, which means this first wire, whichever way it's going to work across here, is up to the system. But let's say here that it's going to start at the left, at my 128 bit. And it's going to send these one at a time. So it's going to look on here and it's going to go, well, it's going to see that there's the 128 bit is set of what it's trying to send. So it's going to pulse, it's going to set that, it's going to set the 128 bit wire. Well, that's the one wire that it has on series. That one data wire becomes the 128 bit wire, and then the clock triggers. So it sets and triggers. And then the next one is going to be 64. It sets 64 to a 1. That's that same wire it's going to use to send it again. So it sets it, and then it triggers the clock again. Then it's moving over to 32 on the same wire. It's going to use the same wire for that. So you're really only using 2 wires at this point. And it's going to send, it's going to clear that. It's going to be a 0, so it's going to be off. It's going to be below the threshold. And then it will trigger the clock. And it's going to do the same thing for 16. Clear clock. 8 clear clock. 4 set clock. 2 clear clock. 1 clear clock. So it's going to end up pulsing that clock 8 times. But you would think that because parallel is sending 8 bits at the same time, that it would be faster. It's kind of like fire running uphill, though, with this. It's an anomaly. And the reason why is that all of these bits have to be set individually on the parallel, and they have to be read individually on the distant end system. Many of our fastest circuits, a lot of our internet, a lot of over-the-radio communication is done in series. A lot of computer internet connections, USB, newer SATA hard drives, a lot of those are done with series communications because series is faster. It's kind of one of those anomalies. Series is faster on the computer. It's faster for it to think about one thing at a time and do it than it is to think about 8 things at a time and do it. It slows it down a lot doing parallel. So a lot of your faster systems are using series. Hopefully that explains it well enough here. So yeah, parallel, it's going to send them all at the same time. Series, it's going to go 1 bit at a time. But that's how it would work as well. It would set. For parallel, it's going to be setting, clear, 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 set, clear, clear, and then trigger that clock wire, and it sent that, and it moves on to the next batch, the next 8 bits, and continues. Thank you for watching.